Geometry, Chapter 9, Section 1. Welcome back, our old friend, Mr. Pythagoras, who came up with the Pythagorean theorem. Again, no new material here. We're just going to polish it up just a little bit, moving into special right triangles in this chapter. So, we have a squared plus b squared equals c squared. Remember, this applies only to right triangles. And it applies to right triangles where A and B are the legs and C is the hypotenuse. Which is the longest side. And it's also opposite the right angle. And so sometimes when the hypotenuse is not given to us, that's how we determine which one is the hypotenuse, excuse me, by looking for the one that's opposite the right angle. So let's take a look at some examples. This will be a fairly short screencast. So in this case, our right angle is here. So this is our C. That's our hypotenuse because it is opposite the right angle. And these are going to be A and B. The most common right triangle in math is the 3, 4, 5. And so if I were to put that in the Pythagorean theorem, that would be 3 squared plus 4 squared equals 5 squared. So that's 9 plus 16 would be 25. And so that makes it a right triangle. Now, because it is the most popular, there are many times where it can save you a little bit of time if you recognize it's a 3, 4, 5 triangle. And we can also take the multiples. So if we multiply this by 2, it would be a 6, 8, 10. And that's also always going to be a right triangle. We could multiply it by 3. That's going to make it a 9, 12, 15, and so forth, all the way down to however many you want to multiply it by. So if you're going to try to identify something as being a right triangle, first look for the 3, 4, 5, and that's a really easy way to not have to do the Pythagorean theorem. However, sometimes you will have to find missing sides, and you won't have that luxury. For example, let's take a look at another one. Again, I'm going to draw in the right angle, and let's go ahead and take some sides. Let's go with 4 and 6, and then we don't know what C is, so we want to solve for C. So that's going to be 4 squared plus 6 squared equals C squared. That's going to be 16 plus 36. 16 plus 36 is going to give us 52. Now, obviously, 52 is not a perfect square. So I'm going to take just a second to pull my calculator out here real quick. Those of you who got your calculators on you, you've probably already got this. And so we're taking the square root of 52 and rounded to the nearest tenth. I'm going to get rid of that equal sign. Rounded to the nearest tenth, it is approximately 7.2. Now we will be testing to see if some are right triangles. So I'm going to pull one up that looks like a right triangle. Actually, I shouldn't do that. I shouldn't. So now I'm going to put some sides on it, and we're going to test to see if it is a right triangle. So we're going to have 8 and 7 and radical 113. So 7, 8, radical 113, just for a different look. So that's going to be 7 squared plus 8 squared equals radical 113. 7 squared is going to be 49. 8 squared is going to be 64. Oh, sorry, I forgot to square the c squared. So if I square 113, the square root of 113, that's going to be 49 plus 64 equals 113. And in this case, that comes out to be true. So this is a right triangle. Make sure you square all three of them. I forgot to put that on there. My mistake. Now, there's also a section that's going to ask if it gives some sides, are those sides, do they form a right triangle, do they form a acute triangle, or do they form an obtuse triangle? Obviously, if you have a squared plus b squared and it equals c squared, then that's a right triangle every time. Our other two, if we're going to have c squared, well, how do I want to write this? Let's write it a squared plus b squared. If a squared plus b squared is greater than c squared, okay, so it doesn't come out to be equal to, it comes out to be greater than, then this is an acute triangle. If the sum of the legs squared, or each leg squared, is greater than the hypotenuse squared, then it's an acute. And so we go the other way. If a squared plus b squared is less than c squared, then that makes it an obtuse triangle. So they'll give you some values to plug in there. And so let's say, no, I don't like these. These use a bunch of how about 15, 20, and 26. Now, obviously, if they give us three sides, it's easy to determine which one is the hypotenuse because it's just the largest. So this is going to be, is 15 squared plus 20 squared. And I'm not going to put an equal to, I'm going to put a box to fill in. And we're going to fill that in here in just a minute. So 15 squared is 225. 20 squared is 400. Got my little box, kind of like my check yes or no box. And then, let's see, off the top of my head, I don't know 26 squared. That is 676. So we add these together, we get 625. $625 is obviously less than 676, and so because the sum of the legs squared is less than, that makes this an obtuse triangle. And that's chapter 9, section 1, the Pythagorean theorem.